All right. So we are looking at properties of logarithms, which we're learning about logs. They are all based on properties of exponents because logs and exponents undo one another, so they're very closely related. You do not need a giant grid like this. It's merely for me. Properties of logarithms is the title, properties of logarithms, and our first property is the products property. The products property the product property says that if I have log base b of u times v, the product refers to the fact that we are multiplying two things together and they're trapped inside of a log, okay? We have a product trapped inside of a log, then we get to expand using the addition of the logs. We get to say log base b of u plus log base b of v. If you have a product, then you get to add the logs. That is the product property. The product property says we get to add the logarithms. Now, that's based on our property with our exponents, which says if I have a product, x to the third times x to the fifth, these have the same base and it's a product. What do we get to do to the exponents? How do you combine them? I'll add them, right? So you get to say, oh, we're going to keep our base the same, and we get to add our exponents. So it's very similar that we get to add our exponents, or here we get to add our logs when we have a product. So do you see that those are kind of related? Similar ideas, okay? All right, so we have another property, the quotient property. The quotient property, quotient refers to division, yeah, so division, if we have a division problem. So that would be log base b of u divided by v. U divided by v. So there is our quotient. It says if we have a quotient, what do you think you get to do? Subtract. Subtract the log. Sure, the product allowed us to add the logs. If we have a quotient, then we get to subtract the logs. Log base b of u minus log base b of v. So if we have a quotient, then we get to subtract the logs, which is kind of nice. You'll notice that it's top minus bottom. And again, it's related to x to the fifth divided by x to the third. If things had the same base in a division problem, in a quotient, what do we get to do to the exponents? Subtract them. X to the top minus bottom. So again, we had a quotient, and we get to subtract the exponents. All right, so again, very, very similar sorts of properties between exponents and logarithms. So here was our quotient, and we get to subtract the exponents. Here we have a quotient, we get to subtract the logs. All right, the very last property is the power property. Okay, the power property says if I have log base b of u to some power p, log base b of u to some power p, the power property log with a power, that power gets to drop right down in front and become P times log base B of U. So the power just gets to relocate to the front of the line, which is kind of nice. I'm not going to talk about how that's related to exponents, but it is. So these are our 3 logarithm properties, and today you're just learning how they work. They're really useful for us when we're solving equations. You have to know the properties to solve log equations. Now, we have 2 sides here. We have the expand side, which expanding means making things appear bigger, making them longer than they started. So we're literally making things just look as long as possible. It's like the really, really long-winded teacher who just talks and talks and talks and talks. All right? Then we have over here the condensed side, where we're making things as compact as possible with only 1 logarithm. Versus over here, we could have 3 or 4 or 5 logarithms together. Okay? So over here, we have the single log side, and then we have the expanded form. And we need to know both. So we start with expand. So we're going to apply some properties. Expand each logarithm using the properties. So example 1 is expand, 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 which means we want to make it as big as possible. And along the way here, I'm introducing you to some notation. We have log of 5 times 8. What is the base? 10. The base is 10. We talked about this yesterday. This is a property. If I have something like the log of x, it is really log base 10 of x. This is called the common log. And this is a button on your calculator. That button on your calculator, the log button, is log base 10. That common log refers to our common decimal place system. We have a 10-digit number system. Our number system is base 10. So our logarithm, we use the common log base 10. It's an implied 10, which means you don't have to write it. If there's nothing there, it is assumed that it's a 10. Always, always. We're going to write it out just so we remember. And when I look at this, I see a product inside the logs. What does the product allow us to do? Add the logs, yes. Log base 10 of 5 plus log base 10 of 8. The product property allowed us to add the logs. That's it, we're done. Oh, yeah. That's the expanded form. We don't have to do anything else with it. That's it. Okay. What if, I have to add one in. A.2. What if you had log of 5 over 8? What property is that? The quotient property, sure. What does the quotient property allow you to do? Subtract the logs, right? Okay, so I can subtract log of the top minus log of the bottom. So here we have the quotient, and it allows us to subtract the logs. That's it. That's the expanded form. Sorry, sometimes after teaching the first time through and hearing the questions, then I need to try again. Make adjustments. Now, letter B is much more tricky. First of all, we have some new notation here. LN. It's really an L. And I don't want to hear from you. I don't want to hear Ellen. Because Ellen is a TV show host. It's been on the air for a lot of years now, right? She's a pretty funny lady. Okay. Please don't say Ellen to me because I'm like, it's like a horribleness, like fingernails on a chalkboard to me. This is actually called the natural log. All right. Natural logs. Anytime you see the natural log of x, it really means log base e. These are the same thing. Log base e, meaning the number e. What is e? Not quite 3. Yes, good job. What is e? Not quite 3. 2.71828. We just learned about that. So e is a naturally occurring number, and so we call this the natural base log, or we shorten it and make it the natural log, Ln. The reason it's reversed is because it's Latin. Just like Spanish and French and Italian, the adjectives come after the noun instead of our weird messed up English. Okay, so we can use ln knowing that it's a log. It still has all the same properties as our log properties. Now, what I want to do whenever I'm working with log properties, the easiest way to do it, which is going to seem weird to you now, but it's actually definitely the easiest way, is make sure that we have no radicals. We want to use exponents as much as we can. And so instead of a radical, I'm going to trade it in for an exponent. So if you remember, the square root of x, I can rewrite as x to what power? Second. Not the second, but 1/2. Because that's the square root of x, we do power over index, so that'd be 1/2. So remember, you can trade out radicals. We want to trade them in for exponents, okay? So I'm going to rewrite this as log base e because the natural log is the same as log base e. And I'm only doing that today just to help you remember. And then I have 7 times 11 to the 1/2 power over x. I have such a hard time teaching this because I could teach it 10,000 different ways and I never know what's the best. Okay, so first, what operation do you see? So you see a product and you're thinking to yourself, what do you need to do? Add the logs, right? You got a product, so you got to add the logs. Okay. I hate doing this. I can't figure out the best way to teach it. I teach it differently every time. And the problem is there's like 10,000 ways to do this. All right, I'm going to go with how I taught it before. All right. So first I said, I don't want to see any radicals. We want exponents. I want to use exponents as much as possible. In fact, I want everything to have exponents. This is 7 to the 1st. Here we have 11 to the 1/2 power, and this is also x to the 1st power. It turns out that the quotient property is rather unnecessary. So I want to use my exponents. And I'm going to take this thing that's in the denominator and lift it up into the numerator. And I can do that because 1/x is the same as x to the -1 power. So I can actually use a negative exponent to lift something out of the denominator. So I have log base e of 7 to the 1st times 11 to the 1/2 times x to the -1. And what I've done is I've gotten rid of an entire property. I don't actually have to use it. okay, which is kind of nice. And now it's just a giant product. What do those products allow us to do? Yes, the product allows us to add the logs. So we have log base of 7 plus log base of 11 to the 1/2 plus log base of x to the negative 1. Yeah, it gets weird, like writing things out. It's just really repetitive, which is why we never go this direction usually. Just today, we will never multiply again like this. All right, so then we've added all the logs together. What do we do with our powers? What does the power property tell us we can do? The power property allows us to move the powers to the front of their logs. So all those powers are going to drop down in front. So we get 1 log base of 7 plus 1/2 log base of 11, and then plus a negative 1 log base of x. Do I have to write plus a negative 1? Now, what does that really just mean? Just to subtract, yeah. So I could just write the subtraction. Instead, I'm going to go ahead and do that. It's really just subtract the log. Now, that seems really long, but I'm curious if now that I reminded you of these rules with exponents, do you think that you could go from here to, say, this step right here? Do you think you could rewrite that now that I've reminded you? All right, we got 7 to the first power. That's there. 11 to the 1/2 power because it's a radical. All right, and then x is in the denominator, so I just wanted to pull it up with the negative exponent. Like you could do that. And then I bet that you could probably go from this step right to the answer, add them all up, and drop the powers in front. Do you think you could probably do that in your head? Yeah, right? So this is about the only time I'm ever going to tell you to use as little work as possible. Okay? It's kind of nice. You can do a lot of this in your head. You'll actually do better just sitting it in your head. Let's do a couple more. Letter C. Yeah, we do have quite a few more. Log base 7 of 3xy over z all to the 4th power. The real reason I'm doing so many examples is because I need to remind you of all of your exponent properties. Making sure you really understand exponents. So my first question to you is, what is this for affecting? Everything in parentheses. And remember, everything always has its own little exponent. 3 to the first, x to the first, y to the first, z to the first, okay? And since this 4 is affecting everything, we have to share that power with everything. So we have log base 7 of 3 to the 4th times x to the 4th times y to the 4th over z to the 4th. And just like before, I want to lift anything in the denominator up. I want to lift everything out of the basement. And how do I move it out? Making the exponent negative, yeah. So 3 to the 4th times x to the 4th times y to the 4th times z to the negative 4th. Very good. So lift it out of the denominator and change that sign to a negative. Oops. All right. Now everything is a product, and what does the product allow us to do? Add all the logs. So log base 7 of 3 to the 4th plus log base 7 of x to the 4th, log base 7 of y to the 4th, plus log base 7 of z to the negative 4th power. Are we done? No. One more thing? What's the one more thing? Move the powers. Drop your powers. That's how I say that. Power play. Drop those powers. They go in front of their own log. And again, it's really expanded right now. Like, look at this expansion we're doing here. It's like the coronavirus. 4 times log base 7 of 3 plus 4 times log base 7 of x plus 4 times log base 7 of y. And then what happens with the last one? It turns negative. Very good. Minus 4 log base 7 of z. That is fully expanded. Fully expanded. No parentheses, no nothing. We want everything fully expanded, no powers. No parentheses and no powers. Wow, I know. All right, log. Log, what's the base here? 10. Okay, there's nothing there. The implied base is there's an implied 10. You don't necessarily have to write it every time. It's implied. We know it's there. Okay, you can write it if you choose. I'm not going to. But I do want to get rid of this radical. My first rule was no radicals. So how should I rewrite that? 7x squared yz. What power can I use instead of the big cube root? Not 1/2. 1/3. Power over index, the index of 3. Okay. Now, what is this 1/3 affecting? Everything. Remember, everything has its own exponent. 7 to the first, x squared. Y to the first times z to the first. We have to share, multiply that 1/3 to all of those exponents. Don't forget anybody. We don't want anybody left out. So we have 7 to what power? 1/3. What's x squared to the 1/3? 2/3, yeah. X to the 2/3. Y to the 1/3. Z to the 1/3. So we are multiplying 1 times 1/3 is 1/3. 2 times 1/3 is 2/3. Now again, we have a giant product. So what are we allowed to do? Add up all those logs. Log of 7 to the 1/3 plus log of x to the 1/3 plus log of y to the 1/3 plus log of z to the 1/3. And then what do you need to do? Drop your powers down in front, they say. One-third log of 7 plus 1/3 log of x plus 1/3 log y. Oh, that's supposed to be 2/3. Thank you. I heard whispers. I knew I made a mistake. Thank you. 1/3 log of z. Woo, Nelly. Okay, questions on either of those? So the big rule here is use exponents, okay? You shouldn't have any radicals. Lift things out of denominators. And then you'll be good to go. Any questions on these? People are still writing. Okay? Step 2, condense. Again, I'm showing a lot of work. If you can do it in one step and get it right, fantastic. Some of you will be able to do that once you realize the pattern, especially on this side, the condensing side. Condensing is what's really important. This is what we use when we're solving equations. We want to put things back into a nice little tight package. All right. So the first thing we want to look for are any powers. If there's any numbers in front, we want to move those back up to their power position. So on the first one here, log of 4 plus 2 log 7. Is there anything that we need to move? The 2 in front needs to go back up to its power position. That gives me log of 4 plus log of 7 squared. And now the directions are actually very important. Once you've moved your powers, then all we have to do is think, is this the product property or the quotient property? Based on, are there positives or negatives? And we only want a single logarithm. How many logarithms should I write in my answer? 1. Just 1 log, a single log. Now, this addition sign, which property allows us to add the logs? The product property. So that addition turns into a product. What are we multiplying? 4 times 7 to the second power. Now, I think the answer key might actually multiply that together and give you log of 196, I think it is. But I don't care. We'll never do this. I like this answer. That just shows me you know the properties. This is very condensed. This is good. Okay. Letter B. Log of base 4 of x, all divided by 5, minus 2 log base 4 of y. So the first thing I want to talk about is this weird divide by 5. There's always a little 1 in front of any logarithm. And I'm going to rewrite this so that it just looks a little bit prettier. Instead of dividing by 5, it's really the same as 1/5 log base 4 of x minus 2 log base 4 of y. And by changing that, what is it now? What does it turn into? X to the 1/5. Yes, it's a power. We get to move the power back up. I'm also going to leave this negative here. Just going to take the 2 and move that up into its power position. So I have log base 4 of x to the 1/5 minus log base 4 of y to the second. Now, is this, what property allowed us to subtract the logs? Division, the quotient property. So we're going to change that to a single log, and it's a quotient. What goes on top and what goes on bottom? It was top minus the bottom. So x to the 1/5 goes on top, and y squared goes in the denominator. The nice thing is, the way I think about it is, if it's positive, then that argument goes in the numerator. If there's a negative in front, then that argument's going to go in the denominator. So positives on top, negatives on bottom. We just have to figure out what goes on top and what goes on bottom. Questions on these two? All right, last one. One more. I'm so hungry right now. I feel like I'm going to pass out. Oh, last one. This is a good one. 2 log base 8 of x plus log base 8 of 5 minus 3 log base 8 of y. What do you want to look for first? Powers. Where are the powers? Hanging out in front. We want to relocate them back up to their arguments. There. This one doesn't have anything in front. Here we have a 3 in front, so I'm going to move that back up. So that gives me log base 8